Welcome to our fourth lesson in the statistics series. This lesson is about statistical diagrams. Today we'll learn how to construct various statistical diagrams such as pie charts, bar charts, line graphs, histograms, and frequency polygons. We will start with pie charts. Pie charts are perfect for quickly showing how a set of parts add up to a whole. Imagine each slice of the circle as a piece of the pie, where the size of the slice matches its share in the data. They work best when you have a small number of categories and need a quick visual comparison of each category's proportion. However, if there are too many slices, the chart can become cluttered and less clear. So keep that in mind when you decide to use this. To construct a pie chart, we begin by gathering and organizing your data into categories or intervals. Then find the total to determine the whole. Next, express each category or interval as a fraction of that total, and multiply each fraction by 360 degrees, which is the total angle in a circle. This tells you how many degrees would represent each category or interval. Finally, slice the pie chart according to these angles and label each section. Now let's do an example. Say you did a survey about the fruits your classmate brought to school today and got the table here. Let's draw a pie chart to compare the proportion of the class that brought each. Next, we will learn about bar charts. A bar chart is a great way to compare discrete categories since the length of each bar represents the value it holds. However, if you're working with continuous data, a line graph or a histogram, which we'll learn about later, might be a better choice. One of the best ways to use a bar chart is when a company wants to compare sales across different regions. A bar chart makes it easy to spot which region performed the best. Creating a bar chart is simple and straightforward. First, gather your data as you did before. Ensure you have a clear set of categories or class intervals along with their corresponding values. Once your data is ready, set up the axes. The horizontal axis should represent the categories, while the vertical axis should show equal intervals to mark the frequencies or counts. Next, draw the bars, ensuring they are of equal widths, and the height of each bar should match its corresponding value. Taller bars represent higher values, while shorter bars indicate lower ones. Finally, don't forget to label both axes clearly so your readers can easily understand the chart. A proper title ties everything together and provides context to the data being presented. By following these steps, you'll have a well-structured bar chart. Here's an example we can try. We are required to draw a bar chart from the table showing the grades students obtained from a test. Now let's talk about a line graph. A line graph is used to visualize data that changes over time. The data points are plotted along the graph and then connected to a line, making it easy to see trends, fluctuations, and overall movement. You should use a line graph when you want to track progress or identify trends over a continuous period. For example, if you are analyzing monthly sales, a line graph can help you spot whether sales are increasing, decreasing, or staying consistent. Unlike bar charts, which are best for comparing categories, line graphs are best for visualizing continuous data. To construct a line graph, start by identifying the variables for each axis. The x-axis represents the independent variable, while the y-axis represents the dependent variable. Once identified, label each axis with the variable name and the appropriate units. Next, provide a clear and informative title that reflects the data being presented. After setting up the graph, plot the points by matching each x value with its corresponding y value. Finally, connect the points in order using either a straight line for direct changes or a smooth curve for gradual trends. Let's look at this example, where we're required to use a line graph to show temperatures at different times of the day. Let's look at something similar to a bar chart. It is called a histogram. A histogram is a great way to visualize how data is distributed. Unlike bar charts, which compare different categories, a histogram groups data into intervals called bins and show how frequently values occur within these intervals. This is useful when dealing with large datasets and you're trying to understand patterns or the distribution of the numerical data. For example, if you have a dataset of student test scores, a histogram can help you see how many students scored within a certain range. For example, 50 to 60, 60 to 70, 70 to 80. This helps identify trends such as whether most students performed well or if the scores are widely spread out. To create a histogram, first organize data into class intervals. Then draw a horizontal axis for the intervals and a vertical axis for frequencies. Label both axes and add a title for clarity. Next, draw bars for each interval, ensuring they have equal width and no gaps since we are dealing with continuous data. This is what differentiates a histogram from a bar chart. Histograms help visualize continuous data trends, making patterns and distributions clear. Here's an example. Let us draw a histogram for the frequency table seen here. This shows a class interval that represents the height of a group and the frequency of heights occurring in that interval. Frequency polygons depends on the bars of a histogram. It uses a line to represent data trends, shown here in green. The bars in the background are just for reference. They are not needed when drawing a frequency polygon. To create it, plot points at the class midpoints of each interval, then connect them with straight lines. This makes it easy to spot trends in continuous data and compare multiple datasets. Use a frequency polygon when tracking performance trends over time, analyzing statistical patterns, or comparing distributions. To create a frequency polygon, start by calculating the class midpoints for each class interval in the frequency table. Label the axes just like you would for a histogram. Then, plot a point at each class midpoint on the horizontal axis with the height representing the frequency. Next, connect the points using straight lines to form a line graph. Finally, extend the line to touch the horizontal axis at the midpoints of the outer intervals or at the base of the first and last interval to complete the polygon. We will create a frequency polygon using the histogram we previously constructed. In this lesson, we covered the construction methods and the use of each type of statistical diagram you're required to know about. Thank you for joining me in this lesson of statistical diagrams. In the next lesson, we will learn about central tendency.